Let's look at number 111O, which is this sequence here. And again, we're looking to find the limit of this sequence and determine whether the sequence converges or diverges. So when we take the limit as n goes to infinity of a sub n, 2 to the n is clearly going to infinity, right? As n goes to infinity, 2 squared, 2 cubed, 2 to the fourth, bigger and bigger and bigger. But same with the denominator, right? 3 to the n plus 5 to the n is going to infinity. These are all exponential functions. And so it's infinity over infinity. Now, some of you might say, well, let's use L'Hopital's rule, right? Which works for limits of the form infinity over infinity. The problem is the derivative of exponentials. These are not power rules. These are exponential rules, right? The derivative of 2 to the n is the natural log of 2 times 2 to the n. And that is not going to really get us anywhere with this expression. L'Hopital's rule doesn't really help in this case. However, if you remember when we're dealing with polynomial functions, if we have a ratio of polynomial functions, one trick was to divide numerator and denominator by the highest degree term in the denominator. These are not polynomial functions, they're exponential functions, but we can do a similar thing, and that is in the denominator here, 5 to the n is kind of a growing more rapidly than 3 to the n. So what I'm going to do is divide both the numerator and the denominator by 5 to the n, or if you want to think about it, multiply top and bottom by 1 over 5 to the n. So I'm multiplying by 1, and when I do that, right, everything up top gets divided. Of course, 2 to the n gets divided by 5 to the n, and then I'll distribute down here, right, distribute that through, and I get 3 to the n divided by 5 to the n, 5 to the n divided by 5 to the n. Well, 2 to the n divided by 5 to the n is 2/5 to the n. 3 to the n divided by 5 to the n is 3/5 to the n. Of course, this ratio is just 1. And now what happens as n goes to infinity, 2/5 to the n is going to 0, right? That's a geometric sequence where r is equal to 2/5, right? Which is less than 1. And so that sequence, that numerator is going to go to 0. The denominator, again, the 3/5 to the n, similarly will go to 0. Of course, the 1 is just staying at 1. And so we end up with 0 divided by 1, which is 0. So that is the limit of the sequence. Since the limit is a finite number, this sequence converges. Okay, so I hope this helps with number 111O.